My talk today is on HTML5 video in Canvas. So I'm just going to jump right into it. My name is Wes Bos. I'm an independent front-end designer and developer. I'm from Toronto, Canada. Any Canadians in the house? Yeah! We're the ones. Yeah. I design and build front-end applications and websites. Huge JavaScript, CSS3, HTML5 fan, and I'm on Twitter at Wes Bos. I'm just going to pause so you guys can all follow me. I'm joking. Oh, I should probably turn my tweet deck off. All right. So this talk is going to review the basics of HTML5 video and its API. So we're just going to start off with some really basic stuff, kind of showing you what it's all about. And then we're going to move into some really cool advanced stuff with HTML5 video manipulation. It's heavy on code and demos, and they're all integrated into the slides, so cross your fingers we don't have any bugs. So HTML5 Video A, this is the official logo of Canada's HTML5 with gnarly grizzly bear, angry beaver. Basics. How many guys have played with HTML5 video before for more than like 3 hours or so? Okay, so a little bit of you. That's good because I'm going to tell you all about it. So HTML5 video is a new element used to embed video into your site along with the rest of your HTML tags. It plays nice and interacts with CSS and other features such as a canvas. Your browser ships a basic video player, but we can use JavaScript to control the player and also how it looks. So this is what a video, HTML5 video looks like in your browser when you bring it up. Super basic. You get a play button, pause button, a little volume button, and a scrub bar. You don't have to do anything to this. It's kind of boring. Support of HTML5 or UG, i.e. Support for HTML5 video is actually pretty good. Chrome 3, Firefox 3.5, Opera, Safari, IE9, all support it really good. Most mobile phones and tablets made in the past couple years are going to support it. In other words, these browsers have supported it for a long time. The only browsers that don't support it are going to be IE7 and 8, which require Flash fallback. So let's take a look at how we do the code. You just pop your video tag in there, and then inside of your video tag, you need to put the source of your video. Because the vendors don't agree on a codec quite yet, we have to insert 2, sometimes 3. For Chrome, Opera, and Firefox 4, we can use WebM. IE uses MP4, but if that person has WebM installed on their box, you can also use WebM. If you're still supporting Firefox 3.5 and 3.6, which you shouldn't, you have to use OGG, and then Safari and iOS use MP4. The order up there is important for iOS, and if the browser goes through all of those and doesn't understand it, you can insert a Flash fallback right about here. In terms of converting them, there's a tool called Miro Video Converter. You can throw it your file, and it'll convert it and spit it out to everything you need. Notable attributes. Video element currently has 12 attributes and constantly in flux. So we have autoplay. Obviously, autoplays doesn't work on mobile. Preload tells the browser to preload either nothing, the metadata, which is the length, the poster, all the stuff associated with the video, or the entire video, which would be useful for something like YouTube, where you're specifically going to a page to watch a video. You want to start loading that puppy as soon as possible. Controls. So remember I showed you like the basic vanilla controls? If you want to hide that, just set it to false. And then a poster is a placeholder image to be displayed while the video loads. So enough of the boring stuff. Let's look at some JS. It's actually pretty easy to get up and running. First, you just need to select it. If you're in the last session, you learned all about query selector. And then once we have that in a variable, we can use some methods to control it. We can play, pause, skip ahead, and even play with the volume. You can control the playback rate, volume, current time, which is enough to make up your own video player UI. You also have access to all the data and properties of the video element. So events, with HTML5 video. Like any element, you can subscribe to events. And then there are a number that are specific to HTML5 video and audio. So for example, here I have add event listener seeking. So whenever you drag the seeking bar, it'll log what I have there. That joke never goes over well. I always thought that was really funny. And then you can do some of the other cool stuff I've seen with it, where you can add an event listener for when someone stops seeking it, and you can go ahead and send that off to maybe your Google Analytics. So if you have an advertiser that's paying for the first 5 minutes of your video, and people are skipping to 5 minutes in, that data can be logged and then sent to your advertiser. So an awesome reference for all the methods is this site on w3.org. It basically shows you all the methods, all of the events that you have access to that you can subscribe to, and then all of the properties that are associated with your current video. So with all of these, you can put together a pretty cool video player. So creating a custom player, like I just said, now that we have access to all the information, we can just use HTML and CSS to create the controls for it. So if we want a scrub bar, it could just be like a nested couple of divs or a couple spans. Same goes for the volume and everything. A few good players that we have is Video.js, JW Player. You guys are probably familiar with that one if you've been doing video on the web before HTML5 came along, because they put out the really flexible, awesome Flash player. And then Media Element.js. All the above have fallbacks for Flash when the HTML5 is not supported. Another great resource is Video SWS, which is See What Sucks. It's an amazing resource to compare the available players. So if you specifically need a couple of features, you don't want to go digging for them, this is just a huge grid of everything that could be, everything that's possible. Adding a dash of CSS3. Because HTML5 video is just another HTML element, we can use CSS to style our player. So this is just a little example I cooked up where it's playing the video. I'm not sure if you can see it, it's super dark, but there we go. And every time I'm hovering over, I'm just using a CSS transition to zoom it in and out. So video and Canvas are our best friends, if you haven't heard. And for that, we get HTML5 video manipulation. Canvas is another part of HTML5 that enables pixel-based drawing. How many of you guys have played with Canvas before? Good. Oh, awesome. It's like most of you guys. So for those who don't know, it's kind of like Microsoft Paint, but for the browser. We can take each frame of our video element and then dump that into a Canvas element and then go forward and play with it. So here's a super basic example that I cooked up. We got a video element on the right here, or on the left, sorry, and we have a Canvas element that's blank to the right. On a set interval, or we can use request animation frame, we just take the frame from the video, and we use Canvas's context and draw image to write the frame or to the canvas. So it's just one line of code that we repeat I like to do it 50 milliseconds or so. And you basically just get a one-to-one. Yeah, there we go. A one-to-one. So video player, Canvas element. Cool, but what can you do with that? Slice and dice. So while a video is playing, we can take those pixels and cut it up into tiles, and then basically do whatever we want with it. For this example, I've just randomized them. And it's kind of a silly example. Last time I did this talk, some guy yelled out, "What's the use of that?" But this is a good example just to show you guys that we have total control over the pixels and how they're displayed on the canvas. So here again, I have just a video element. And then when I play it, I'm spitting it into this canvas right here. And then I'm taking the pixels from this canvas and then spitting them into a larger one down here and just randomizing the pixels and the blocks of everything.
To the land of the gatekeepers.
Sorry, so dark, guys. I didn't realize that would be like that. So filters and pixel manipulation. Canvas has a method called getImageData, which returns an array of every single pixel available. Better yet, we have access to the red, green, blue, and alpha channels of every single pixel. We can take these pixels, play around with them, change them to whatever we want, and then stick them right back into the canvas. So let's loop through like a little basic example that I've cooked up here. We have our video element, and we have a canvas. And then we use JavaScript to grab hold of the elements and get the canvas's context. So query selector, there we go, and we get the context. And then I also created a variable called example4pixels, which I'm going to use to store everything that I grabbed from the canvas. Now that we're set up, we have 4 steps to repeat every 50 milliseconds or whatever frame rate you really choose. What we want to do is we want to take the frame from the video and dump it into the canvas. And then what we want to do is grab the pixels from the canvas and store in our variable. And now that variable now has every single pixel from the canvas. And we want to loop over it and then adjust the RGBA channels accordingly. And then when we're finally done, we'll take that variable of pixels and spit it right back into our canvas. For simplicity, I'm using a single canvas, but it's often a good idea to have one for manipulation and one for showing. You don't always need them on the screen. You can hide them, but I'm just using one in this case. So first step, take the frame from the video, like we saw that a little earlier. Grab the pixels from the canvas and store in our pixels variable. So we use the canvas method called getImageData. Tip here, don't console log your pixel array because it can get into the millions and it'll totally crash your browser and you'll have a really sad tab. And now here's where we loop over the pixels that are available to us and adjust our RGBA channels. So the way it's set up is that every 4th number is a new pixel. So we have red, green, blue, alpha, red, green, blue, alpha. So I just have a simple for loop here. And if we go to the next one, you'll see that I have red, green, blue. I'm not playing with the alpha right now. We'll get into that a little later. And then I'm just taking that exact value, adding 100, minusing 50, and multiplying it by half. So when we then play that, the end result is kind of just like a red tint over the video. And that was only like, I don't know, 10 lines of code. And we're able to create kind of a super simple little filter. WebRTC. Who's here has heard of it? Okay, who have heard of it just this weekend? Because I heard a couple other people. Okay. So WebRTC is real-time communication on the web. It's something new that's coming down the pipe, and it allows for browsers to communicate with each other directly. It's still under heavy development, but we're able to create something called a peer connection, which allows for a one-to-one channel between 2 peers. So what this means is we're able to stream audio, video, and eventually data and files over this peer connection without relying on a server in the middle. So think if you want to send your friend a file, you're not sending it to a server and then sending it down. You're just sending it straight into his browser. We would only need like WebSockets or an AJAX request to do the initial handshake to connect the 2 peers. And the real benefit here is that we're going to be seeing HTML5 chat roulette pretty soon. So stay tuned. So say hello to Get User Media. Peer connections aside, this stuff's really cool. But with this new spec means that browsers are currently implementing native webcam access and microphone access. That's right, no Flash plugins required for this. Get User Media is currently supported in Opera Mobile 12, Google Chrome Canary, which is what I'm using right now. And then I was just told by our Boot to Gecko guys that it should be coming August-ish. Is that right? What about Firefox as well? Awesome. Well, that's going to be really good. So there's some logos for you guys. So let's take a look at a demo then. I'm going to start it up, and then Chrome asks me, oh, can you access your camera? And you're able to select which one you want. Click Allow, and gives us a little notification. So what I've got here now is a video right here. This is a little canvas, which I'm going to run some manipulation on, and then my big canvas right here for outputting everything. So my first effect is kind of a hipster Instagram effect, which I've used similar to like the red one that we just did. Threshold, which is kind of cool. I took one of these algorithms from, I forget what it was, but you can kind of get the outline of my body. Blur. So I'm using a stack blur algorithm here to just make a blurry overlay on top of my video. And then you can kind of really step it up and do something like HTML5 green screen where, oh, it is working, sweet. So the way green screen works is that you take a thing, it usually has to be well lit, and I basically took this green bag because I couldn't find Bristol board at the dollar store. And I took a picture of it, and I ran it through a canvas, and I went through every single pixel on here, and I found the maximum and the minimum RGB values of this bag. And then I inserted it into my thresholds right here. And as this streams here, any pixel that falls between that threshold is just, we take it totally out. So this usually requires like really good lighting. I'm just going to adjust it a little to see if I can get it working a little better. So that's with my face. I'm not sure if, yeah, there we go. Lighting here is kind of crappy, but we're able to do that green screen effect with just, again, maybe 10 lines of code. And then one of the other ones is my favorite is HTML5 glasses, which basically tracks your face using something called Community Core Vision, and it takes the frame, scans it, finds a face, and just appends these kind of funny glasses on it, and it'll follow me around kind of wherever I'm going. So, oh, thanks. Just a quick word on performance with that, because it can be slow. Iterating over a large canvas takes more processing power because we're basically going over every single pixel in the canvas. When you're doing pixel analysis, if you can, it's often a good idea to run the process on a smaller version of the canvas and then spit it out onto a larger one, which is why I had a video element and 2 canvases going there. I used to get 1 to 2 frames per second on like an 800 by 600 canvas. I tried WebWorkers. It didn't speed it up very much. And simply running it on 100 by 100 pixel canvas improved the performance by at least tenfold. So a large canvas is slow, but you have better accuracy. A smaller canvas is fast, but is less accurate. So I'm just going to pop up in my larger canvas demo here. Oops, allow my camera, and turn on the glasses. And you can see how like this is going like kind of slow for me. But if I think I can bring it over to the audience, I'll see if I can get any of you guys on it. No, you know what? It's too dark. But does any of you guys want to run up here and get some glasses on with me? Come on. Oh, you guys. Nobody wants to have glasses on? Yeah.
Well, try to put glasses on my lip.
Yeah, sometimes you get false positives.
It's more interested in putting them on my face.
Here, come on up. So I did this at another conference, and it had awesome lighting on the audience. So I was able to get about 13 people with glasses on. And like, you can also do it with this magazine that I found in my hotel room. So I'm obviously doing very important things in the web right now. So speaking of important things, where do you find this stuff in the real world? Popcorn.js, who's used it before? Sweet, you guys are awesome. Built by Boku and Mozilla, allows you to create interactive HTML5 web pages that sync up with the video or audio element. So this is kind of like cue points if anyone's coming from Flash or any other video stuff. And they have a huge library of plugins that work with everything from Twitter to Google Maps, Street View. So you can kind of queue up content to some video that you have. DMV, also by Rick Waldron, who wrote a lot of Popcorn. It uses WebRTC, NodeJS, and WebSockets to create an online photo booth and save images to the server. And it's 100% JavaScript, which is really cool. You guys should check it out. OSX photo booth effect. So I think it is Paul Neve, sorry. Oops. He created this tool that is pretty much like photo booth, but with WebRTC for the web. So he's gone ahead and created like every single effect that you can think of and just done it. This is 100% in Canvas and JavaScript. And there's like 100 different like effects on here. Kind of a cool, you can take a photo and post it to Facebook. The fire one is my favorite. So definitely check that out. So get user media shim. The stuff is really cool, but we can't use it, right? Because it doesn't work in like all the browsers. Well, no, because we can use shims and polyfills to recreate the functionality for older browsers. Adi Osmani, he wrote a shim that provides a Flash fallback to this. It gives you the same API for the webcam. Here he sent me this, which I don't know if you can see it, but basically this is using Flash, and he just hooked up my face detection script, and it worked great. The Wilderness Downtown, this is like a year and a half old, but basically what they did here is it's Arcade Fire music video, and they kind of mashed together the video and a bunch of Canvas stuff and a bunch of cool web APIs all into one like really interactive music video. Same kind of thing at Rome. This is done by, I think, Mr. Doob and the Google people. And basically, it's this really cool 3D canvas where it brings in the music video and all these 3D animals running around. And you can kind of navigate through the video as you wish. So much cool, so little time. Check what time we got here. Oh, we're doing pretty good. If you want to see more of this stuff, check out the Chrome Experiments page. They got all kinds of cool stuff. So augmented reality is the last thing I'm going to talk a little bit about today. I'm kind of new to this, but it's really cool, and I thought I'd show you a bunch of stuff. In the same way that we analyzed the pixels in the last example, we can use an augmented reality library to detect any sort of markers that we train it to do. So here I'm using something called JSAR, which is a port from FLAR, which is a Flash augmented library. And then a wrapper called by the guys at Boku. So I'm just going to give it a start. Again, just pulling myself into a canvas right here. No big deal. But what I've got here is I printed out some of these markers, and I've set it up to do different things with the marker. So when I bring a marker in front of it, it tracks where I'm going, and appends kind of like an image that we have set up for it. And then I've set it just to change the background color of my slides. So this is pretty cool because it just follows it right around. And you can tilt it back and forth. and follow it right around. And then the even cooler thing about that is that you can then take your 3D models that are from like Blender or something and export them and kind of just let it append to here, and you can tilt it around and let it follow. So that is that. To summarize, HTML5 video is super awesome. You can use JavaScript to control every single aspect of it. Canvas makes manipulating video fun and easy, and I encourage you guys to go out and make some really cool things. So thanks a lot, and I'd love to take any questions that you guys may have. You can either just yell it out, or we have this mic that apparently no one's using. Yeah?
I was kind of curious, a lot of your effects have to do with on one pixel at a time.
Yeah.
Except for the blur, and it wasn't a slave with the blur outwards. Does that give you something special to get that?
To get that, basically what that does is it, from what I understand, is it does loop through every pixel, but it takes that pixel and the neighboring pixels into account, and then kind of takes an average of them. And then it does that maybe 5 or 6 times. There's a couple different blur algorithms out there, but that's the one that I'm using is like that.
My point is that there's 5 pixels you're averaging, it's like 5 times as slow.
Yeah.
It didn't look slow to me.
No, it didn't. It was actually pretty smooth. You should take a look at the face detection library, because it was going really slow. Like that thing is a mammoth because it's looping through a bunch of pixels looking for a face. So you can actually do quite a bit before you see any like frame rate droppage. Yep. That was a library called JSAR, which is JS Augmented Reality, and it's a port from the Flash library. And basically, these things are just numbers, and it can just it just takes it and tells it where it is, and we pen the image. Yep. It's actually coming. There's a really great Google group called WebRTC Discuss or something like that, and it hasn't been implemented at all yet, but they are going to be implementing an API for recording video. Alternatively, what you could do is capture the frames from this canvas and store them and play them back. Yep. Yeah. As far as I know, yes, you have to dump it into a canvas. There may be some stuff, but nothing that I've heard of. I don't know. Does anyone know? Okay. Yep. Okay, so the face detection library is something called Community Core Vision, or CCV. And it was basically they put together a little demo that showed how to do it on a photo. And I kind of adapted that to work with a real-time streaming environment. No problem. Yep. Yep. I actually don't know what they're using there, but I do know that there was like a 1 hour, I haven't watched it, but there was a 1 hour Google Hangouts WebRTC session. So I wouldn't be surprised if they have their own library for doing the face detection. Same with the iPhone. When you have your camera on someone, there's a little face detection thing on it. So there's probably a couple libraries out there. This one's open source, so not exactly sure what they're using. Yeah, definitely. That'll do it. All right. Well, thanks a lot, guys, and I'll be at office hours after this if you need anything.